Hi, and welcome to the Worldwide Center of Math's problem of the week. This week we have a probability problem. The problem is, if you roll 4 fair 6-sided dice, what is the probability that at least 3 of them will show the same value? So because this question asks for at least 3 of them, basically what we want to do is break this up into 2 cases. Case 1. So case 1 is that 3 dice show the same number and 1 dice shows a different number. And case 2, that all 4 dice show the same number. So what we're going to do is first solve for case 1. So breaking case 1 down, basically 3 dice will all show the same number, and there's 6 possible options for what that number can be. And then the last and final dice, 1 dice will show a different number with 5 possible options for what that number can be. Since we know that the 3 dice will all show the same number, that narrows down the options for what the last dice can be by 1. So there's 5. So in terms of probability, what that really means is that out of the 4 dice, 4 choose 3 will show possible 6 numbers, and 4 choose 1 will show 5. And for those that don't know the N choose K formula, it goes like this. So n choose k is n factorial over k factorial times n minus k factorial, and it's used a lot in probability. So using that for the probability that 3 dice will all show the same number and 1 dice will show a different number, this over the total kind of options of what the different dice can roll, which is equal to 6 to the 4th for the total. There's 4 dice, and there's 6 possible options for numbers that each of those dice can be rolled as. That ends up coming out to be (6 times 4 times 5 over 1,296). And what basically happens in terms of the numerator here is that this 4 choose 1 actually ends up coming out to be 1, so it actually disappears, and then this 4 choose 3 turns out to be equal to 4, so it just turns into 4 times 6 times 5, and then 6 to the 4th, 1,296. So now that we have the probability that case 1 happens, what we can do is find the probability that case 2 happens, that all 4 of the dice show the same number, add them together, and we'll have the probability that at least 3 of them will show the same value. So case 2 is that all 4 of the dice will show the same 1 number. And what that means in terms of probability is that out of the 4 dice, we will choose all 4. And then there's 6 possible options for what number all 4 of them will show. So just times 6. And that ends up coming out to be 6. The 4 choose 4 is equal to 4 choose 1, which is just 1 when you solve it out using this n choose k formula. So now we have the probability, and then this is over the total probability of the entire event of different options that the dice can roll as. So it ends up coming out to be over 6 over 1,296, and that's the probability that case 2 happens, that all 4 of the dice roll the same number. So now we have the probability for case 2 And we can just add these together, 120 over 1,296 and 6 over 1,296. So putting both of these together, what we get is 4 choose 4 times 6 plus 4 choose 3 times 6 times 4 choose 1 times 5 over 6 to the 4th, which simplified turns out to be 6 plus 120 over 1,296, and simplified even more, 126 over 1,296, and breaking that down, it turns into 7 over 72, which is about 9.7%. So there's about a 9.7% chance or probability of this event occurring that at least 3 of the 4 fair 6-sided dice will show the same value. So that's all we have for you today for this week's Problem of the Week. I hope you enjoyed watching this video. Please check out some more of our videos on YouTube, check us out on Facebook, and follow us on Twitter. Thank you.